Thanks everyone for joining. Today I'm going to talk about how we are using NEO to essentially bind the physical and digital world, which is something that's really exciting for me and was very exciting to put together. So with that, let me get started. As mentioned, we'll cover today how to catch a thief, and this is basically a blending of how to do these things all together at once. But the key is to do it within seconds, right? The key thing here is fast. Obviously, if somebody's stolen a device, then they're not going to be sitting there for long, or may not be sitting there for long, right? Speaking of time, this is, of course, a technical webinar. We usually try to keep these under 25 minutes, so I'll do my best to get through this, but there is a lot of ground to cover. Real quick about me, I've been in the industry for 20-something years at this point. Was at Cisco Advanced Services for about 9 of those years and spoke at Cisco Live for the last 5 I was there. This product that you're looking at today, LogZilla NEO, is about 15 or so years in the making. It was started as an open source project back in 2004. So here we are today with NEO. NEO is network event orchestration. The biggest problem that's always been prevalent in the industry with just your standard kind of log tools is that they don't really do anything. They just, they give you analytics or they tell you to go fix something. But what we wanted to build was something that would go fix it. Engineers have this problem that they end up chasing known problems, things that they know how to fix all day long, or at least half their workday. It's kind of a waste of time when you have to keep doing the same things over and over again, right? So the other part of that is we wanted to build something that could actually scale. And I don't mean just, scale as in today's standards, but really redefining what that standard is. So if you're interested, we've got a video we can send to you that's recorded that shows this high scalability. At Cisco Live this year, we showed this new version that was on a single $4 an hour Amazon instance, indexing about 10 terabytes a day. So very, very fast. But today we're going to cover the learn and resolve part. So learning means being able to connect to other systems, gathering intel on those systems, and being able to compare what we have versus what we've collected, right? Next part of that is to resolve it. So now we get to make an informed decision about what to do after we've got that information. The same as an engineer would do, right? They're going to go out and they're going to collect this information. They're going to figure out what to do next, right? So let's learn. A couple of questions come up in this scenario. First of all, what do we need to know? What do we already know? And how are we going to get a physical location of something? Well, we've got the device's MAC address. So our customer gave us a list of MAC addresses for the device's stolen serial numbers, things like that, right? So we're going to find where it's physically located. We've got the police case number that was opened on it. We've got the detective's name, his contact information, and whether it was just lost or stolen. Obviously, we don't want to send in the drones if it was just a misplaced device. And then finally, because of that, we need to be able to make a final decision. We could just as well have LogZilla NEO detect if it's stolen, because there is a marker for that, whether it's stolen or lost. And if it's stolen, just send it right to the police immediately. But our customer asked for a way to be able to stop it right at that end of the process and provide a mechanism for confirming that they want to send the drones. Ha, I like that. All right, so what do we already know? We've got the MAC address, the police report, detective name, and whether it's stolen or lost. How are we going to get the location of it? Well, we looked at the resources available, okay? And out of obviously more than just a few tools, these were the ones that we narrowed it down to. We're going to use wireless, obviously. So we've got Cisco Prime, we've got Cisco ICE involved here. And we also had the option of maybe using the hardware, right? The next question becomes, what's the easiest and fastest way to get this information? Remember, this is about time, okay? So do we look at Cisco Prime, ICE, or the controller itself? Well, we looked at Prime and we tried to connect to the API. We had a problem where a single query took about 33 seconds, and that's just not fast enough, right? We looked at ICE. We looked at connecting the API, had a similar problem with that. It was a little bit faster. It was also a layer of complexity where the engineers that we were working with were concerned about, okay, we get Cisco's SDK, we make this work, and then Cisco releases a new version and somebody's got to go make all these changes. And it was just a little bit too complex for them to work with, right? The other side of that is they do have ICE logging to LogZilla Neo, but those logs are a little unclear, right? So when you turn on logging with Cisco ICE, this is what you get. There's a bit more information, but it's a lot of these strange step equals and a number, right? But it did have the controller name. It didn't have the access point that the user connected to. The wireless LAN controller, we could do a direct SSH to it, but in order to do that, we need the CAPWAP ID from Cisco ICE in order to figure out which access point or which WILC to connect to, right? But then we go, wait a minute, now the logs had that, right? So Cisco ICE had that. So now we're going, we've got a match, we have a winner. Now we have the CAPWAP ID and we have a way to get the access point. We're not going to go through Prime because it was too slow. We can go directly to the device itself. Okay, so if we look at sample events coming in, we've got the ICE logs with the CAPWAP 287 here, and then we go to the device and do a show CAPWAP summary and include that, and now we have the name of the access point. Well, in our customer's case, guess what that is? The access point name, right? So let's look at that breakdown of what the way that they name their access points. S-Bus is School of Business, room 237, and the AP number, right? So here we go. We're ready, right? Dr. Evil's ready. So we're going to tell him to hold off a minute. We're missing a whole bunch of stuff still, aren't we? We've still got to figure out how to do the MAC address, the police report number, all this stuff, and then that final decision. So what do we do with this, right? Dr. Evil said he wanted to go. With Neo, LogZilla Neo, you can create event enrichment on the fly, and that's done by collecting information from disparate sources. You can go out to an API, grab this, a database, grab that, pull all of this information and put it all together, and essentially create a virtual pool of knowledge so that when the event comes in, we're able to already precede or enrich that data with information that's not normally found in a log or a trap or any number of ways that you can get information into LogZilla Neo, right? So we need all of these things. We know we can get the MAC address from the ICE logs. We know we've got our police, our quote unquote detectives information, and we've got our controllers, and we have whether it's stolen or lost, but we need to wrap it all together, and we're going to use that final decision through Slack, right? So their team uses Slack. If you're not familiar with it, it's a messaging platform that's far better than email. One of my complaints as an engineer was always getting 300 emails a day that got filtered to a folder that I never looked at because, well, it's just too much, right? So Slack enables things like bots and callbacks and a lot of wonderful things. And again, in LogZilla Neo's case, it's not a bunch of messages saying this is broken, this is broken, this is broken. It's, you know, a message that says this was broken and I fixed it. Thank you. So let's work on the combination of stuff. We need to combine these known values with events that match some variable coming in, right? So we know that the events have a MAC address in it when that student comes up, whether it's a DHCP registration or ICE or whatever the case may be, okay? And then we're going to add it as metadata to the event. So we end up going from an event that looks like this with the ICE logs to an event that looks like this. Now we've got device name, the MAC for the wired MAC, the wireless MAC, serial number, all of that stuff is now in there. Okay, next thing we're going to do is coordinate that information. So we need a trigger. In LogZilla Neo, we have a simple method for you to create a trigger that says, look for this, do that with it, okay? So match on X and forward to Y. In this case, we're gonna forward it to a script. And that script is what's gonna go to the WILC and SSH to it and log in and do the show commands, right? From there, we're gonna extract the WILC's IP and that CAP WAP ID. Right? You can see those on the right here. Next, we're going to compare the AP name to a list of building codes. Remember, now we only previously had the AP name that maybe somebody knows what that is, maybe they don't, but I can bet the detective's not gonna, so we need to translate that into plain English. So at the same time, we've got an input file of building codes where SBUS means student business building, for instance, right? And then next, we're going to extract that enriched meta that we added earlier and then format it and make it pretty and put it up to a Slack channel for approval. Okay. So real quick, we're going to talk about a rule. So we've got triggers and we've got rules. Rules are a mechanism that allow extraction and transformation in real time. And the key here is real time. So as an event comes in, even if it's at hundreds of thousands of events per second, you're still not going to slow this thing down. The engine itself is fast enough to process in the millions of events per second. Right, so you can match on any of the data coming in. Here's a list of some of the things you might match on. In our case, we're going to match on the message itself, but we're also allowed to create user tags, what we call user tags, and that is an extraction of that data into some other what would be analogous in a database to a column, right? We could split it out so that you could do things like tracking the number of stolen versus lost devices, things like that, right? And you can use standard matching type things, regular expression, or just string matches or number matches. So here's a sample rule from our stuff that's coming in today. Now we know the MAC addresses, right? We're going to match on the value of either the wired or wireless MAC. The file that was given to us had notes in it, so we just put that as the comment in the file. But let's break this down for a second, right? MAC1 or MAC2, that's fine. We'll use a regular expression to do so. And then we're going to create the tags that we talked about a moment ago, right? So now I can track device names and the types, okay? Now we're just going to update and add all the metadata that we've already gotten to the message. You can see this macro $message here is the original message, and now we're just going to append everything to the rest of the message. Okay, so some of you are maybe feeling a little daunted by regular expression, pretty industry standard at this point, I don't know, 30 years. So one of the things we did here was to try to make it easy for you. So if you've got key value pairs like you've been seeing in these messages, something equals something, you don't have to write a pattern at all. It'll automatically recognize that it's a key value, and all you do is just call it as if it were already captured variable. You don't have to do anything. So we've got something like device name equals whatever. Now we can add a tag that says device name. Very, very simple to do. Okay, so now we've got everything that we have to put together: collect, coordinate, and combine, right? We've done all that, but we don't have our final decision. So the final piece of this is that Slack piece where we want to have a button that humorously says send in the drones. Now in our customer's case, they probably wouldn't put something like that, but I like to have fun with things. Okay. And then you can see an example here of the email that comes in, right? Emails can be formatted however you want. You could do HTML and make it pretty if you want, but for the purposes of this, we just did set the subject line. We've got a case number. We could have just as well sent the text message to the detective's phone. But you can see that translation from SBUS AP number to something more digestible for him. We've located the device. It's at University Hall, room 5105, right? Okay, so that's the how. What I'll do now is I'll actually go through the interface and a couple of the things that were put together for this. And give me one moment here. I'll share my screen. All right, there we go. So this is the LogZilla Neo interface. You can see I've created a dashboard here for people that lack moral compass. Some of the default dashboards that come with it, sample dashboard will just show you kind of events per second. Notice everything here is real time. No matter how fast things are coming in, it still updates every second. Okay, there's a couple of other key things here. Obviously, we're big on scale, but we're big on saving the customer money in terms of total cost of ownership. If you can do this on one server versus half a data center, it's going to end up costing you a lot less money to do all of this stuff in terms of just data management itself. Now, in LogZilla Neo's case, of course, you're going to get that ability to do the event enrichment and coordination and event correlation and all those kind of things, right? So if we look at something like our ICE events coming in, remember I said we can extract and transform, and we can carve those out into other things. So now we can track things like the classes and endpoint policies and all that kind of fun stuff, right? But let's take a look at our moral compass tracker. We can see our friend Brian here has a stolen device and somebody's gotten a hold of it, okay? Now I'm going to show you this process, and the entire process, remember I said it has to be fast. So this demo is going to go for about a second. Everything in our world, again, is about speed. Let me go over here, and I am going to kick this off and to generate a script, and you're going to see it pop up. So there it is. So at this point, our network operations center can look at this, look at the notes, see if they want to do it, and we're going to click deploy troops. It's not just going to send that information to the detective, but let them know which user, in this case it's the demo user, confirmed that click, right? Because if somebody makes a mistake, then they of course have a way to know who did it. But another interesting thing here was being able to get the data in and out. Now their servers are behind a firewall, Slack is public, so there were some other things here for callbacks and stuff like that that is going to be very hard to cover in 25 minutes. Maybe we'll get to do another webinar on that. Or you guys can actually just contact us. Be happy to show you as well. So let's go back over here. We can see the events have come in, and we're going to verify that we've gotten the email, which you saw on the slide. Obviously, I'm not going to show my personal email on a webinar, but it looks identical to what I just showed you there on the last slide. So remember I said that was going to be a quick demo. Now think about everything that we just put together, that entire time with all of that. We've got all of this, and it took 1 second for everything to happen, okay? So we've got the event, we've got the location, we've got the student. Now Mr. Detective walks into the classroom and points a finger at somebody and says, hey, let me see that thing you're holding there. Whether it's a cell phone or a laptop, or I looked at the customer's input data. There was even Xboxes in there, so doesn't really matter. Now, in the case of wireless versus wired. Wired's actually much easier because you can just go to the switch port and figure out which one they're logged on to and get the same information. You wouldn't have to go to the WILC to get the data, right? All right, so we're at about the 20-minute mark. Yeah, a little bit over. So I think we'll make that a wrap.